So this is my response to the discussion this week. Hello class. So today we're gonna work with decimals using blocks. So the first question I have for the class is, if the rod represents one whole, what does the flat represent and how do you know this? So here is a rod and here is a flat. So do we know how much ones are in a rod? Well, we can count. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 ones in one rod. So now we know that one of these is 10, right? So if we're looking at a flat, each one of these rods is 10, right? So let's count how many of those are in this flat. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 rods in a flat. Now we know that. So 1, 2, 3, 4, and 5, 6, 7, 8, 9, 10. So we know all 10 of these is one of these, and all 10 of these is one of these. So, going back to our question, if the rod represents one whole, what does the flat represent? The flat represents 10, right? Because you need 10 rods to make a flat. So that's what we would write down. And that's going to be our answer. So that's how we're going to answer these. So moving on to the next question, if a rod represents one whole, remember this is a rod, then what does the small cube represent? So we already discussed this in the last problem. So what's the answer? It's 10, right? 10 of these goes into one rod. 10 cubes goes into one rod. Good job. Okay, so question 3 is, if a flat represents one whole, what does the large cube represent? So this one's a little bit tricky, huh? So we know that there's 10 rods in a flat, which means 100, right? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? So there's 100 cubes in a flat. So if there was 10 rods in a flat, how many flats do you think are in a cube? Does anybody have a guess? 10, right. So why do we think there's 10 in there? Well, we can easily count how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 flats in a large cube. Okay guys, so now we're gonna work on the next couple of problems. So this is the table that we're gonna be looking at, and it's talking about lunch. So it's kind of like how you guys eat school lunch every day, right? So we're gonna be talking about lunch and how we can relate that to math. So for our first question, we're gonna talk about, for the lunch described, what percentage of the total protein comes from the cup of whole milk? So the lunch described is 1 cup of whole milk, 2 slices of pizza, and 1 cookie. So the question is asking for the total protein that comes from the whole cup of milk. So we're looking at the lunch and we see that they only got 1 cup of whole milk. So let's write that down. And if we look back at our chart, how much protein is in 1 cup of milk? Can anybody guess? Can anybody see by using the chart? 8, right? It says it right there. 1 cup of whole milk has 8 total protein. So we will say that equals 8 protein. So we know that equals 8 protein, right? But it's asking for percentage of the total protein that comes from the whole milk. So we can also see that there's 2 slices of pizza that this person is eating. So how much protein is in 1 slice of pizza? 11, right? We can see it right there. But there's 2 slices of pizza. So what will we do? 11 plus 11. Good job. So for the pizza, we're going to be doing 11 plus 11. Can anybody tell me what 1 plus 1 is? 2. What about 1 plus 1? 2. So 11 plus 11 is 22, right? So pizza would be 22 proteins. And then finally, this person is also eating 1 cookie. How much protein is in 1 cookie? 2. Good job. So we know that the cookie equals 2 proteins. So let's do 22 plus 8. Does anybody even know what 8 plus 2 is? 10. Good job. So we're going to make sure to bring the 1 up here since it was 10, right? Then 2 plus 0, 2. But we got to add that 1, so it would be 3. 30 proteins. And then we can't forget about the 2 proteins from the cookie. So what's 30 plus 2? That's 32, right? That's an easy one. So since 32 is our total, that's going to be our bottom number. Because remember, we learned about fractions the other day. But we're specifically trying to figure out how much the whole milk percentage is of proteins in this entire meal. So we're going to put 8 above that. Okay, so we got our 8 over 32, and we're going to equal that to x over 100 because we're trying to figure out what percentage the milk is out of 100% of the proteins in this meal, right? So does anybody remember what we learned when we learned about fractions? Is that we can cross multiply these. Isn't that crazy? So if we cross multiply these two, we're going to get 800. And if we cross multiply these two, we're going to get over 32. So now we got to divide that, but this is really hard to divide when it's like this, right? So we're going to change this into some long division. So you put 800 in the box and you put 32 on the outside. So can 32 go into 8? No. Can 32 go into 80? Not 1 times, but 2. Good job. So 32 times 2 is 64. We're going to subtract 64 from 80. Which leaves us with 16. Can 32 go into 16? No. So let's bring the 0 down. How many times can it go into 160? Raise your hands, please. 5. Correct. It goes exactly into 5. So that gives us our answer of 25. So it's 25% of the entire proteins. And that's our final answer for question 1.